So hi everyone, this video is about my activities here in chapter 6, which entitled as the network layer. So watch this. Let's start. First, we will launch course. So we will go to chapter 6 and then we will find the first activity here. So the first activity is located at page 6.1.2.6. So its instruction is read each IP characteristic. Then click connectionless, best effort, or media independent to indicate its delivery method. So it's an first will send a packet even if the destination host is not able to receive it. So it is the connectionless because the destination host is not able to receive the packet. So next, packet delivery is not guaranteed, so it is best effort. Next, we'll adjust the size of the packet sent depending on what type of network access will be used. So it is the media independent. Next, no contact is made with the destination host before sending a packet. It is a connectionless. Fiber optics, cabling, satellites, and wireless can all be used to route the same packet. So it is the media independent. Last, does not guarantee that the packet will be delivered fully without errors. So it is for best effort. So it's all correct. Now we will proceed on the next activity. And the next activity is located on page I think I'm sorry, I forgot topic 3. So the next activity is located here in page 6.1.3.3. This activity was entitled as the IPv4 header fields. It is a part 1. Read each IPv4 header function and then click the IPv4 header field to which it belongs. So, identifies the IP address of the sending host. It is the source IP address. Identifies the priority of each packet. So it is the differentiated services. Identifies the upper layer protocol to be used next. It is for the protocol. Commonly referred to as a half count. So it is the time to leave or the TTL. Always set to 0100 for IPv4, so it is the version. And lastly, it identifies the IP address of the recipient host, so it is the destination IP address. So okay, we will go to the next activity. And the next activity is here at page 6.1.4.6. Read each IPv6 header description and then click the IPv6 header field to which it belongs. When this value reaches 0, the sender is notified that the packet was not delivered. So, it is the hop limit. So next, it classifies packets for congestion control, and this is the traffic class. Next is always set to 0110, so it is the version. It is same as in IPv4 that is always set on 0100. Next, identifies the size of the data portion of the packet. So it is the payload length. Next, to suggest that all packets receive the same type of handling by IPv6 routers. So it is the I think this is the flow level. Oh, it's correct. Next is it identifies the application type to the upper layer protocol, so it is the next header. So now we will go on to the next activity. So the next activity was here at page 6.2.2.8 that has the title of Identify Elements of a Router Routing Table Entry. A partial router routing table entry is shown. Each section of the entry is identified by a circled letter above it. Select the correct routing table entry section for each output. So, first, the elapsed time since the network was discovered. So it is E. Next, the administrative distance or source and metric to reach the remote network. It is the letter C. Next, how the network was learned by the router. So it is A. Shows the destination network. It is on letter B. Next, the next hop IP address to reach the remote network is on letter D. Next is the outgoing interface on the router to reach the destination network, and it is letter F. So let's check it. It's all correct, and now we will proceed on the next activity. So the next activity is here on page 6.3.1.7, and it has a description of router functions and hardware parts. Descriptions of router functions and hardware parts are provided in the table. Drag each router component name to its function and description. So first, connects routers to external networks, usually over a large distance. So it is the WAN interface, the wide area network interface. A way to remotely access the CLI or the command line interface across a network interface. It is the telnet or the SSH or secure shell. Next, connects computers, switches, and routers for internal networking. It is the LAN interface or the local area network interface. Next, a local port which uses USB or low-speed serial connections to manage network devices. It is the console port. And last is a port to manage routers using telephone lines and modems. So it is the auxiliary port or the AUX port. So let's check if it is all correct. So it's all correct, and now we will proceed on the next activity. So the next activity is located here at page 6.3.2.6. And this activity was entitled as the router boot process. And drag each of the steps on the left the appropriate field in the table on the right to show the router boot process order. So in step 1, we will put the perform POST or the hardware check performed by built-in or ROM chip. And the step 2 is the load bootstrap that is copied from the ROM to RAM that locates the iOS. And the step 3 is the load the iOS, the operating system file for the router loaded into RAM after Bootstrap finds the iOS file to be used. And step 4 is to load the configuration file from the flash or NVRAM. So that's all correct. And now we will proceed on the next activity here in chapter 6. So I think there is an activity that is included on every notes here. So we will check if where it is. So we will check. So it has a bookmark, so I think so this is the activity or the practice. Basic router configuration task. So enter the global configuration mode to configure the name of the router as the R1. So we are in exec mode, so we will go on privilege exec mode and we will put the enable. Next is we will go to the global configuration, so configure terminal, and we will put the host name for the router. So configure class as the secret password. So we will put enable secret and then class. So configure Cisco as the console line password and require users to log in. So we will put the line console 0, and then we will put the password Cisco, and we will put login. Configure Cisco as the VTY password for lines 0 through 4 and require users to log in. Then exit line configuration mode. So we will put the line VTY 0 and 4. So password Cisco, and then login and exit. So encrypt all clear text passwords. So to encrypt password, we will put the service password dash encryption. Enter the banner authorized access only and use the sharp as the delimiting character. So banner MOTD and then the sharp authorized access only. Exit global configuration mode, we will exit. So you successfully configure R1 with initial settings. So next, we will go on next activity like that. So it is the configuring LAN interfaces. Configure the gigabit Ethernet 0/0 interface. So we will put the configure terminal, and enter configuration commands 1 per line. It is interface gigabit Ethernet 0/0, and then we will put the IP address 192.168.10.1 and its subnet mask, which is the 255.255.255.0, and we will put the description LAN 10 and no shutdown to active the interface. So configure the gigabit Ethernet for LAN 11 as it is same as the first activity we made. So configure define the interface gigabit Ethernet 0/1 and the IP address of it 192.168.11.1 and the subnet mask is the 255.255.255.0. And next is describe the link. So description LAN 11 and no shutdown. So successful configure the R1 LAN interface. So next activity is here at next activity is here on page 6.4.3.2, which is the configuring a switch default gateway. So enter global configuration and configure the 192.168.10.1 as the default gateway for S1. So we will write the configure terminal and then we will put the IP default dash gateway and its IP, which is the 192.168.10.1, and let's check. So you successfully configure the default gateway on a switch. So I think there is no more activities here, so we will return to class. Thank you for watching this video, and I hope you enjoy and understand my video. And I hope also you learn from this. So I'm Kisha Lyka Villanueva of IT 2105.